is the last section in Unit 2 for geometry, which covers symmetry. So we're going to start with a quick little warm-up on reviewing stuff that we've already done. Starting with number 1, this one, just identifying the transformation, would be a rotation. Now, some people were arguing that the red shape does not look exactly like the blue shape, and you can make that argument. That's fine, but I'm going to make the argument. It still looks like a rotation. So then for number 2, this one would be a reflection because it just mirrors itself. And then for number 3, we need to rotate triangle ABC by the given angle, which is 180 degrees. So I'm going to start just by plotting ABC. So that is at 1, -5, 1, 2, 3, 4, 5, and then 7, -1, and 3, 0. So then because it's 180 degrees, I am going to be making it a -x, -y. So my A prime would be at -1, +5. B prime would be at -7, 1. And C prime would be at -3, 0. So then if I plot these on the graph, oops, and I didn't connect my dots for my other one. My bad. Boop. But plotting A prime, -1, 5 would be up here. B prime is at -7, 1, and C prime is at -3, 0. And then you'll notice that when it is all done, it looks like we have rotated around the origin. And remember, because I had that distance with the origin to my first triangle, it's going to have that same distance on the other side when it's 180 degrees. So, real quick, rigid and non-rigid transformations is probably what you would expect. A rigid transformation keeps the size and shape of the pre-image, and a non-rigid keeps the shape but not the size. Shape but not size. So thinking about the transformations that we have done, a rigid transformation would be a reflection or a rotation or a translation. And then the one that would be changing the size would be a dilation. So now the last one that we're going to be talking about is symmetry. And a figure has symmetry if there is a transformation of the figure such that the image coincides with the pre-image, aka it looks like a mirror image of itself. So if you look at these 2 arrows, if we were to cut them horizontally, they wouldn't look the same on the top and bottom. But if I look at the picture as a whole, I can draw a line and it looks the same on both sides, so they would be symmetrical to each other. So then, with these little arrow pointer thingies, just looking at the individual shape, I can cut it down the middle like this. Oops, that wasn't quite straight. But I can cut it down the middle, and it looks the same on both sides of the shape. But if I wanted to look at it as a whole between the 2 shapes, I could also just draw my line right there. So then the last one that I have are these little stars. And notice that with these stars, I can't draw a vertical line and it actually be symmetrical on both sides. But with the stars themselves, I can draw a point through the high points like this. So that gives me 2 lines of symmetry. And then with this one, I can also go vertically and horizontally, which you can do to both of them. So each of these have 4 lines of symmetry. Now, I've been saying the words, but now this is the actual official definition for you, that a figure has line symmetry or reflection symmetry if it can be reflected across a line so the image looks like the pre-image. So noticing the shape with the heart, my line of symmetry would be this arrow because it cuts that heart in half and makes it look the same on both sides. So looking at these shapes, you might be able to pretty quickly tell which one has line symmetry, but can you figure out how many are in each shape? So starting with this little starburst thingy, I can go through all of the high points and it will make it a symmetrical shape or cut, if you want to call it that. And so I have 4 of those right off the bat just by looking at the high points. But I can also look at these low points, and with those low points, that also makes it symmetrical. And that gives us an extra 4 lines of symmetry. So for this shape, we actually have 8 total lines of symmetry. And I'm going to abbreviate. Now with the triangle, taking a look, we can't cut it horizontally and we can't cut it vertically to make it symmetrical. So this one actually has no symmetry. And then with this little plus sign thingy, looking at it, you can pretty easily tell that it has that vertical symmetry and horizontal symmetry. And then you just kind of have to guess and see if it can be cut diagonally. So looking at this one, I would say that that is close enough that it is symmetrical on both sides. So then this one has 4 lines of symmetry. Okay. So then rotational symmetry is our last bit. And with rotational symmetry or radial symmetry, a shape can be rotated up to 360 degrees, but can't be actually 360 degrees, so that the image coincides with its pre-image. So if you think about like a rectangle, I can turn a rectangle 180 degrees and it still looks like a rectangle because the top part would then be the bottom part, but it still looks like a regular rectangle. But if I have to turn a shape 100 or 360 degrees, like let's say a heart, with 180, it would look like an upside down heart. So it would not be rotationally symmetrical. But with that extra 180, it would look like a regular heart again. But since it's a full turn, can't have that. So looking at the alphabet, we want to figure out which ones have rotational symmetry. So looking at the letters A, B, C, and D, none of these letters, if you were to rotate them around, would ever look the same until you got to 360 degrees. So none of these have rotational symmetry. Then we get to E, F, G, and H. E would not have rotational symmetry, neither would F or G, but H would have rotational symmetry because at 180 degrees, it would look like an H again. So then we have I, J, K, and L. I would have rotational symmetry because it would look like an eye again before 360 degrees. But J, K, and L are no-goes. They don't work out. Then with M, N, O, and P, M and P do not work. They do not have rotational symmetry, but N and O both have rotational symmetry. Then we have Q, R, S, T. And all of these, well, 3 of the 4 definitely do not have rotational symmetry. And then with S, some people make the argument that the bottom part looks the same size as the top part, at least with this S. So you can totally say that that one has rotational symmetry because it'll look the same when it's upside down as well. Then with U, V, W, and X, as you might have predicted, only X has rotational symmetry. And then with the last 2 letters of our alphabet, Y and Z, Y does not have rotational symmetry, but Z does, because again, if it's upside down, it still looks like a Z. So then the last example, we want to just describe the symmetry. So we're going to identify if it is a line symmetry or rotational symmetry. So with this first picture, assuming that we don't consider the labels for the letters as part of the picture that we're looking for symmetry, we can cut this diagonally with a line on both sides. So because of that, we have line symmetry. And then if we were to turn this picture 180 degrees, we would also have rotational symmetry. So this has both types. So then we look at this black little box inside a box, and many of you would probably see that there is definitely line symmetry because we can cut it in half. But then we also have rotational symmetry because with this, if I turn it 90 degrees, it still looks like the same box within a box. And if I turn it another 90 or another 90 or another 90, it would still look like that box within a box. So this one also has both line and rotational symmetry. And then last but not least, the little smiley face guy. Looking at this, he would not have rotational symmetry because he would not look the same if we turned him 180 degrees or 90 degrees or anything like that. So no rotational with this one. But we do have line symmetry, but only on the vertical end, because then he would have an eye on both sides and the mouth is cut in half. So he does have line symmetry. And in case you don't see it, the reason why he does not have that horizontal line is because he does not have the two little circle eyeballs on the bottom half of his face. So, oops, didn't want to get rid of the pink line. Oh well. All right, so that is the end of symmetry. Your homework is on page 637. Keep in mind, you do not have to tell me an angle of rotation or an order of symmetry by those directions. If this video is helpful, be sure to give it a like and subscribe to the channel so that you get updates on when new videos are posted. Please let me know if you have any questions and just comment below. Thanks for watching.